Hello friends, in the last video we see the question number 1 to 7. Now in this video we will learn the question number from the question number 7 second part up to the question number 24. The remaining question, that is a word problem for the question exercise 4.5 and 4.6, that will take the afterwards. I will make the small video on that two word problem. Now let us start remaining problems of the exercise 4.6. Now let us start the key question number 7. Verify that A in bracket B plus C is equals to AB plus AC. The second part is the matrix A 1 minus 3 3, 1 minus 1 and 3, 2 3 2, and B is 1 0 minus 2 3 4 3, and C is equals to 1 2 minus 2 0 4 minus 3. Now first of all we will consider the LHS, that is A in bracket B plus C. 1 minus 1 3, 2 3 2, and next is B, that is a 1 0 minus 2 3 4 3, and the next matrix is 1 2 minus 2 0 4 minus 3. And in this way we have first of all addition of that two matrices. That is, add the corresponding elements, then you will get matrix, their addition. Now the multiplication, first row first column, that is 1 into 2 minus 1 into minus 4, 3 into 8, that is the first element. Next is first row second column. Now see this, next is second row first column, and last is, now you can see this, after addition you will get 30 minus 1 8 13. This is number 1. A in bracket B plus C. Next is RHS. AB plus AC must be there. By mistake it is written AB plus AC. Second matrix A. Now this is the B plus now we'll change it AB plus AC. We write here the matrix A again, that is 1 minus 1 3, 2 3 2, next is 1 0 1 1 2 minus 2 0 4 minus 3. Now the corresponding multiplication. for the first two matrices, first row, first column, first row, second column, next is second row and first column for the given first two matrices I am considering, and next is second row, second column. Now the first part is clear. Now here we add here what is for remaining two matrices. Now see this: first row, first column, first row, second column, second row, first column, second row, second column. Now the multiplication is simple multiplication. Concentration is needed for this type of multiplication. Their respective addition: 2 minus 6 plus 6, 0. Next is 9 and 6, 1 plus 2 plus 12, 2 minus 0 minus 9. Multiplication given in the second bracket. Now we add this. First is 15, 6 to 15, and the next, this is the addition of these two matrices. 15 minus 7, 4 minus 2. Therefore, 30 minus 1, 8 and 13. Now see this, this is the number 2. Therefore, from 1 and 2, we have A in bracket, A in bracket B plus C is equals to AB plus AC, and hence it is approved. Now next, question number 8. If A is 1 minus 2, 5, 6, B is equals to 3 minus 1, 3, 7, and therefore find AB minus 2I, where I is unit matrix of order 2. Now the order of A and B is 2, therefore whenever we take the identity matrix, the order must be 2. Now see this, the multiplication. Number of the students says that, sir explain karo, aap likhte jate ho. Now I had written very clearly, first row, first column, first row, second column, second row, first column. This is the one. Second row, second column. Now see this. If you see this, you can get it. That is a 3 minus 6 minus 1 minus 14, 15 plus 18 minus 5 plus 42. Therefore 3 minus 15, 33 and 37. Now next is AB minus 2R. That is minus 3 minus 15, 33, 37 minus 2R, 1, 0, 0, 1. Now multiplication. That is minus 3. Small mistake was done there. Now I am repairing it. Therefore, the first is minus 5. Now next is like this. You can see. Therefore, minus 5, minus 15, 33, 35. This is number 2. Question number 9. A, B matrices are given. The order of A is 2 by 3 and the order of B is 3 by 2. Show that AB is non-singular. Now first of all we will find out the product AB and then we will find out the determinant AB. Now see this. The product, multiplication, first row, first column, first row, second column. Now see these particular elements which I am making the multiplication. Then second row, first column of the second matrix. Second row, second column. Therefore, you will get 4 minus 3, 2. Next is 8 minus 4, minus 1 minus 2. Next is minus 2. Therefore, the matrix is 3, 4, minus 3, minus 2. Now we will find out the determinant of AB. If it is singular, then the determinant of this mat AB is 0. If it is non-singular, then determinant is not equals to 0. That is a 3, 4, minus 3, minus 2. Therefore, you will get minus 6 and minus in bracket minus 12. That is minus 6 plus 12, that is equals to 6. Therefore, AB is not equals to 0. Therefore, AB is non-singular matrix. Number 10, question number 10. If A is equals to 1, 2, 0, 5, 4, 2, 0, 7, minus 3, find the product A plus I, A minus I. Now here A plus I means identity. Here we will take identity of the order 3 by 3 because the given matrix A is of the order 3 by 3. This is A plus I. Next is A minus I. This is the A minus I. Now we will find out their product. A plus I into A minus I. Now the matrix A is A plus I is and next matrix is A minus I. See this. Now their multiplication. First row, first column. Now see this. First row, second column. Now this is the big multiplication. Then second row, first column. second row, which is the second row is row of the first matrix, and column we take the second matrix column. Second row, second column. Now see this. Second row, third column multiplication is carried. Third row, first column. Third row means third row of the first matrix. First column means first column of the second matrix. Now see this, the product. It's easy one. Multiplication, there are the number of the numbers. That's why you have to carry out very sincerely their product. Now we'll see their product. See this. And next is, and third row of their product. Normal product is there. I am not repeating all each and every steps. You only observe that steps, that is a 10, 10, 4, 25, 39, 2, 35, 7, 22. Therefore, a plus I into a minus I is equals to 10, 10, 4, 25, 39, 2, 35, 7 and 22. And the answer is different from the textbook. You can check it. If you are correct, then you are correct. I had solved in this way. Next, if A is equals to alpha 0, 1, 1 and B is equals to 1, 0, 2, 1, find alpha if A square is equals to B. This is the expression we have given. Means what we want to do? We will find out A square and equate it with B. Now A square means what? A into A. That is a alpha 0, 1, 1. Alpha 0, 1, 1. Now again first row, first column. Next is, in this way we can form their product. That is alpha square 0, alpha plus 1, 1. Therefore alpha square is equals to, A square is equals to alpha square 0, alpha plus 1, 1. Now we have given that A square is equals to B, alpha square 0, alpha plus 1, 1 and that's equals to 1, 0, 2, 1. Therefore alpha square is equals to 1. Therefore alpha is equals to plus or minus 1. But alpha plus 1 is equals to 2 and that's why we will take the value of the alpha is equals to 1. See this? Now I am taking for this example. Someone asked me, sir, you pause the video. Now you can write this. But it takes too much time. Instead of that, you pause the video and write it. Next is the value of A square is alpha square 0, alpha plus 1 and we have given that A square is equals to B. Therefore equate it. We will get their value, that is alpha is equals to 1 the value of alpha is 1. Next is question number 12. Now the question number 12, if A is equals to 1, 2, 2, 2, 1, 2, 2, 2, 1, show that A square minus 4A is a scalar matrix. Now we'll form their product A into A that is 1, 2, 2, 2, 1, 2, 2, 2, 1, again 1, 2, 2, 2, 1, 2, 2, 2, 1. Now their multiplication, first row, first column. Now see this, how I am going to multiply this. You will get it notice. First row, first column, first row, second column, first row, third column. Now my first word means first row means what? First row of the first matrix. And next I am saying that column means the column of the second matrix. And now in this way. Now which is now third one, that is a second row, third column. Now next will be, what will be the next? Third row, first column now. Third row, first column. Third row, second column. See this element. Row is continuously constant, but the columns are changing. That is, the bracket numbers are changing. Therefore, the multiplication is very important. There should not be any mistake when you carry out the multiplication. That we call my silly mistake was there, and hence my example was wrong. Now this is the multiplication. See this? The last. Now their corresponding addition is there now. 9, 8, 8, 8, 9, 8, 8, 8, 9. Next is A square minus 4A is 9, 8, 8, 8, 9, 8, 8, 8, 9 minus 4A, that is 1, 2, 2, 2, 1, 2, 2, 2, 1. Now multiply it with 4, therefore you will get 9 minus 4. You multiply it. That is the first is. Write down the matrix as it is. Minus 4, 8, 8, 8, 4, 8, 8, 8, 4. Nine minus 4, 8 minus 8, 8 minus 8. Very simple explanation is here. Subtraction, corresponding elements, then you will get 5, 0, 0, 0, 5, 0, and last is 0, 0, 5. This is the scalar matrix. All the diagonal elements are same. Therefore, it is a scalar matrix. Now, next is question number 13. If A is 1, 0, minus 1, 7. Find K so that A square minus 8A minus Ki equals to 0, where I is a unit matrix and 0 is a null matrix of the order 2. Now what is here? Now we'll first find out A square. How to find out A square? A into A. Therefore, it is written in this manner: 1, 0, minus 1, 7. 1, 0, minus 1, 7. Next is 1, 1, 0, minus 1. 1, 0, 7. 1, minus 1, 1, 7, minus 1. Minus 1, 0. Plus second row, second column, 7 into 7. Therefore, now see this there multiplication. It's very simple again. That is 1, 7, minus 1 minus 7, 49. 1, 7, minus 8, 49. Therefore, A square is equals to 1, 7, minus 8, 49. A square minus 8A minus Ki is equals to 0. Now substitute the values. 1, 7, minus 8, minus 49. 8A, that is 8 into 1, 0. Minus 1, 7, minus K in bracket 1, 0, 0, 1 equals to 0. And we can write this. Normal simplification is here. K 0, 0, K equals to 0 matrix. We want to find the value of K here. 1 minus 8 minus K. 7 minus 0. Minus 8 plus 8 equals to 0. 49 minus 56 minus K. Now see these corresponding elements. Minus 7 minus K. 7, 0. Now minus 7 minus K, and that's equals to 0, 0. The value of the K is I think that this example is repeated. You can see now. Let's find out the value of A square. First row, first column. Now last is second row, second column. You can see this. This is the repeated now. Repeated steps are here. This is the A square. Next is A square minus 8A minus Ki is equals to 0. The value of A square is 1, 0, minus 8, 49, minus 8, the value of the A, 1, 0, minus 1, 7. There must be minus ki minus ki must be there. If the small mistake is there. Now see this. No, that is 1 minus 8 plus k, 0. Minus 8 plus 8. 49 minus 56 plus k, that is equals to 0. And now we will change their sign now. And the last I get the value of k. Now change the minus sign. I am changing this sign. Minus sign must be there. Therefore, that is minus 7 minus k is equals to 0. Therefore, k is equals to minus 7. This is the value. Sometimes there is a mistake finally also. And the example is repeated. Now, question number 13. Now see this, the question number 13. If a is 1, 0, minus 1, 7, find k. That is a square minus 8a minus ki is equals to 0. Now, where I is unit matrix and O is 0 is the null matrix of the order 2. Now, first of all, we will find out the value of a square. That is the example was repeated. That was repeating again the third time. If question number 14, a is equals to and b is equals to the matrix, and then a plus b bracket square is equals to a square plus ab plus b square. Now first of all, we will consider the LHS. That is a plus b bracket square means, that is first of all a plus b into another bracket a plus b therefore in curly bracket, that is 8, 4, 10, 5, 5 minus 4, 10 minus 8, bracket complete into the same bracket is repeated there, 8, 4, 10, 5, plus sign must be there in between them. Therefore, their addition is a 13, 0. And next is 20 minus 3 in the next, that is 13, 0, 20 and minus 3. One mistake was there in the second bracket, there must be addition sign, plus sign must be there. Now first row, first column, first row, second column. See this multiplication, that's why I had written the column numbers are in rounded bracket, then and then you will understand. Now second row, first column is carry out, and second row, second column. Now see this, their multiplication. Next is 20 into, that is their multiplication, a plus b bracket square, (209). That is the second row. Now what about the RHS? That is in RHS a square plus ab plus b square. Now a square means what? A into a. AB. B square means what? B into a. 8, 4, 10, 5. 8, 4, 10, 5. AB means what? 8, 4, 10, 5. And the value of B, that is the matrix B, is 5 minus 4, 10 minus 8 plus B square means what? 5 minus 4, 10 minus 8 into 5 minus 4, 10 minus 8. Now their multiplication is 8 into 8. First row, first column. 8 into 8, 64. 4 into 10, that is 40. Next is first row, second column. 8 into 4, 32 plus 20. Next is second row, first column. 10 into 8, 80. 5 into 10, 50. Next is 40 plus 25, and in this way we have carried out number of the times multiplication. Now you see this, how the multiplication is carried out by observations. You will get the idea, because in all these videos not a single example is remaining. Whatever the remaining examples I am concluding in the next video. Only the 2 word problems are there. See this, and this is the b square, the value of the b square. Therefore now their respective addition will be there. You see this, their addition: 104, 52, 130, 65 plus 80 plus 80 must be there. I had written 8, but 80 must be there. I will change it. Now see this, 80, and change it. That is, the total addition is 169. Next is 0. Sometimes it gets difficult writing on the tablets. On the tablet, that is, next is 200, and last number is 9. Therefore this is 2. From 1 and 2, LHS is equals to RHS. So this LHS and the RHS both are the same. Therefore a plus b bracket square is equals to a square plus ab plus b square. Now next, question number 15. If a is equals to 3, 1, minus 1, 2, prove that a square minus 5a plus 7i equals to 0. LHS is equals to a square minus 5a A plus 7i. Now normal matrix is there whose order is 2 by 2. We can perform their multiplication, number of the times multiplication. This is the drilling exercise for the multiplication. That is the 3 1 minus 1 2. Again 3 1 minus 1 2 minus 5a. That is the 3 1 minus 1 2. And last is 7 1 0 0 1. Now the a into a. 9 minus 1, 3 plus 2. Next is second row, second column. That is 15, 5 minus 5, 10 plus 7 0 0 7. And now their respective addition, algebraic addition. That is 8 minus 15 plus 7, 5 minus 5 plus 0, minus 5 plus 5, 3 minus 10 plus 7, and that is equals to 0, 0, 0. Therefore, it is a proved null. Therefore, a square minus 5a plus 7i equals to 0 is proved. If now next is question number 16. If a is 3 4 minus 4 3 and b is 2 1 minus 1 2, show that the two matrices A and B are given, then show that A plus B into A minus B is equals to A square minus B square. Therefore, LHS is equals to, in bracket, A plus B, A minus B, and their product is like this. That is, first find out the value of A plus B. That is a 3 4 minus 4 3 plus the B matrix, that is a 2 1 minus 1 2, and next is A minus B, that is a 3 4 minus 4 3 minus, in bracket, the B matrix, that is a 2 1 minus 1 2. Therefore, 5 5 minus 5 5 into their subtraction is, that is 1 3 minus 3 1, and that's why now their product, the order is 2 by 2, and that's why the again very normal multiplication is there, number of the times is repeating, we are repeating here, and that's why first row first column. But till sometimes I think that I must repeat it, first row first column, first row second column, until and up till second row first column, now second row and second column, in this way, so that you will get more and more practice from me. Now their multiplication, normal multiplication is there. Now see this, the multiplication. That is minus 10 20, minus 20 minus 10, and in this way. Now the RHS, that is A square minus B square. Now find out the value of A square, means what? A into A. B square is B into A. That is 3 4 minus 4 3, 3 4 minus 4 3 minus 2 1 minus 1 2, 2 1 minus 1 2, Now the multiplication, first row, first column, first row, second column. Second row, first column, and second row, second column. Minus in bracket, again their respective multiplication. Every time I am taking these longer steps, but when I actually teach, I write their product directly, but you can understand by using these steps also. In each and every examples I have written in this manner. That is the first row, second column multiplication is there. Now see this, that is minus 1, 2, 2 minus 1, minus 1, 1 and plus 2 into 2. Now see this multiplication, that is a 9 minus 16, 12 plus 12, minus 12, minus 12, minus 16 plus 9. Now next their respective addition, that is 4 minus 1, 2 plus 2, minus 2 minus 2, minus 1 plus 4. And therefore you will get minus 7, 24, minus 24, minus 7, minus in bracket 3, 4, minus 4, 3. Now their subtraction, minus 7 minus 3, 24 minus 4, minus 24 plus 4, minus 7 minus 3. Therefore minus 10, 20, minus 20, minus 10. This is number 2, therefore from 1 and 2, LHS is equals to RHS. That is A square minus B square, hence it is approved. Now next question number 17. If A is equals to 1, 2, minus 1, minus 2, B is equals to 2A minus 1B, and if A plus B bracket square is equals to A square minus B square, find values of A and B. Find the values of A and B. Now again the sign was changed there, there is also correction. That is, since A plus B bracket square is equals to A square plus B square, and they can be written as A plus B in first bracket, A plus B in second bracket, and their respective product, that is the first A into A square, A into B, AB, then B into A, that is B plus B square. Now cancellations, A square, B square on both sides get cancelled, that is AB plus B is equals to 0. Normal multiplication is there, you can understand this, that is AB is equals to minus BA. Therefore we will write first is A, then B, 2A minus 1B, and next is minus in bracket 2A minus 1B, and next is A, 1, 2, minus 1, minus 2. Now make their product, that is a first row, first column, first row, second column, second row, first column, second row, second column. Now on the right hand side, same multiplication is there. First row, first column, first row, second column. First row, second column, and second row, first column, and last is second row, second column. Now see this multiplication. Therefore, their multiplication, first is 0, a plus 2b, and next is 0 minus a minus 2b, that is 2 minus a, 4 minus 2a, minus 1 minus b, minus 2 minus 2b, and that's why 2 minus a is equals to 0, a plus 2b, minus a minus 2b. Now we'll apply the minus sign here, that is a minus 2, 2a minus 4, b plus 1, 2b plus 2, equating corresponding elements, that is a minus 2 is equals to 0, therefore a is equals to 2, and b plus 1 is equals to 0, means what, b is equals to minus 1. In all these examples, there is a practice, matrix multiplication practice is there. Now question number 18, find matrix X such that AX is equals to B, where A is equals to 1 minus 2 minus 2 1 and B is equals to minus 3 minus 1. Now we perform their product. The order of matrix A is 2 by 2 and the order of B is 2 by 1. Therefore, the order of their product is 2 by 1. Now next is, let X is equals to AB, that is a column matrix. Then AX is equals to B becomes 1 minus 2 minus 2 1 AB, that is equals to B matrix, that is a minus 3 minus 1. Now their product A minus 2B minus 2A plus B, that is minus 3 minus 1. A minus 2B is equals to minus 3. Minus 2A plus B is equals to minus 1. This is equation number 2. Therefore, A minus 2B is equals to minus 3 and minus 4A plus 2B is equals to minus 2. We will add these two equations. Now we will write that is equation number 3. Then 1 plus 3, that is A minus 2B is equals to minus 3. Minus 4A plus 2B is equals to minus 2. minus 3a is equals to minus 5 and a is equals to minus 5 upon minus 3, that is a 5 upon 3. Therefore, put a is equals to 5 by 3 in a is equals to 5 by 3 in equation 1, that is a minus 2b is equals to minus 3. 5 by 3 minus 2b is equals to minus 3. Therefore, 5 by 3 plus 3 is equals to 2b, and their addition, that is a 5 plus 9 upon 3, that is a 2b. Therefore, b is equals to 14 upon 3, 14 upon 3 into 2, and that's why b is equals to 7 upon 3. Therefore, x is equals to 5 by 3 and 7 by 3. These are the value of the x matrix, the value of x. Now next is question number 19. Find find the value of k if a is equals to 3 minus 2, 4 minus 2 and a square is equals to k minus 2r. A square is equals to a into a, 3 minus 2, 4 minus 2, 3 minus 2, 4 minus 2, and their product, first row, first column. Next is first row, second column, second row, first column. Next is second row, second column. Therefore, 1 minus 2, 4 minus 4. Now k minus 2i, that is a 3 minus 2, 4 minus 2, minus 2, 1 0, 0 1. Therefore, you will get 3k minus 2k, 4k minus 2k, that is a 2 0 0 2. Therefore, you will get 3k minus 2 minus 2k, 4k minus 2k minus 2, that is a square is equals to k minus 2i gives. Now we will equate this, that is a 1 minus 2, 4 minus 4, this is the square, and k minus 2i, that is a 3k minus 2 minus 2k, 4k minus 2k minus 2. Therefore, by equating the corresponding, that is equality of the matrices, that is 1 is equals to 3k minus 2. Therefore, 1 plus 2 is equals to 3k. Therefore, k is equals to 3 upon 3. K is equals to 1. 20. Example number 20. The first is 1x1, 1 2 3, 4 5 6, 3 2 5, 1 minus 2 3, and that's equals to 0. Find the value of x. Therefore, now perform their product. Now we write the first of all example, that is equals to 0. Now the multiplication 1x1, the multiplication of the 3 by 3 and 3 by 1 matrix. That is first row, one column is there, therefore first row single column, second row single column, second row single column, that is the first column. Therefore we are getting the 1 minus 4 plus 9 and their respective addition is 6, 12, 14 equals to 0 and first row first column, that is overall you will get the single value because the order of the first matrix is 1 by 3 and the second is 3 by 1, therefore the order of resultant matrix is 1 by 1, that is a single element. 12x plus 20 is equals to 0, therefore 12x is equals to minus 20 and that's why x is equals to minus 20 upon 12, that is a minus 5 upon 3, therefore x is equals to minus 5 upon 3. Now next example, example number 21. Find x and y if 4 in bracket the matrix 2 minus 1 3 1 0 2 find the value of x and y if, now see this, that is 4 in the bracket 2 minus 1 3 1 0 2 minus in bracket 3 minus 3 4 2 1 1 into 2 minus 1 1 and equals to xy. Now simple multiplication is there on the left hand side. Now it is first matrix is multiplied with by 4, therefore their respective multiplication is there, and on the right hand side xy, therefore 8 minus 3 minus 4 minus in bracket minus 3 12 minus 4 4 minus 2 0 minus 1 8 minus 1 and that's equals to 2 minus 1 1, that's equals to xy. Now perform their respective algebraic addition, that is 5 minus 1 8 2 minus 1 7 2 minus 1 1 equals to xy. Now the order of first matrix is 2 by 3 and second is 3 by 1. Two by 3 and 3 by 1, therefore resultant order is a 2 by 1. Now first row first column, that is first element, second row first column, that is you will get only the two elements are there, which are 19 and 12, therefore x is equals to 19 and y is equals to 12. This is the answer. Question number 22. Find x, y, z if 3 in bracket 2 0 0 2 2 2 minus 4 in bracket 1 1 minus 1 2 3 1 bracket complete, and next column matrix 1 2 x minus 3 y minus 1 and the 2z. Now the normal multiplication is there, that is 3. We are multiplying this 3. First of all, we'll write the example. Minus 4, that is 1 1 minus 1 2 3 1 1 2's, and on the right hand side x minus 3 y minus 1 and 2z. Now their multiplication is, that is a 6 0 0 6 6 6 and 4, 4 minus 4, 8, 12, 4, 1, 2, and on the right hand side x minus 3, y minus 1 and 2z. Therefore, the respective algebraic subtraction is there. 6 minus 4, 0 minus 4, 0 plus 4, 6 minus 8, 6 minus 12 and 6 minus 4, and that's equals to x minus 3, y minus 1 and 2z. Therefore, you will have, that is a 2 minus 4, 4 minus 2, minus 6, 2 and 1, 2. Therefore, on the right hand side x minus 3, y minus 1, 2z. Now their respective multiplication. First row, first column, that is the last one, single column is there. Next, second row, first column, that is only one column is there. And third row, first column. Therefore, equate it, you will get the value of x, y, z. That is minus 6 is equals to x minus 3, and therefore x is equals to minus 3. Equating the corresponding elements. Equating the corresponding elements. Minus 6 is equals to x minus 3, therefore x is equals to minus 6 plus 3. Next is x is equals to minus 3, and last is 2z is equals to minus 2, therefore z is equals to minus 1. Y is equals to 1. That is 2z is equals to minus 2 and z is equals to minus 1. Now next is 23, question number 23. If A is equals to cos alpha sin alpha minus sin alpha and cos alpha, show that A square is equals to cos of 2 alpha sin of 2 alpha minus sin of 2 alpha and cos of 2 alpha. For this, we want to find out A into A. This is the A matrix. Now see this, very simple multiplication is there because we have performed too much multiplication. Now next exercise is very easy, that is a 4.7, but before that in this exercise we have covered too much multiplication of the matrices. That is cos alpha sin alpha minus sin alpha cos alpha sin alpha minus sin alpha cos alpha. First row, first column, that is cos square alpha minus sin square alpha. Sin alpha into cos alpha plus cos alpha into sin alpha. Next is minus sin alpha cos alpha minus sin alpha into cos alpha, and last is cos square alpha minus sin square alpha, and therefore the value of cos square alpha minus sin square alpha, that is we have completed the first of all trigonometry. You can remember the formula is cos square alpha minus sin square alpha is cos 2 alpha, next is sin of 2 alpha, take the minus sign common, and next is also cos of 2 alpha, and that's why you are getting cos of 2 alpha sin of 2 alpha minus sin of 2 alpha and cos of 2 alpha. Hence it is proved. Therefore, hence it is proved. Now the last example, that is a question number 25. that is a word problem, and one word problem from the exercise 4.6. I will make the separate video on these two word problems. The number of the students are asking, sir, you have not solved that example. Now I will solve that example in the separate video. That is, if a is equals to 1, 2, 3, 5, show that AB is not equals to BA, but determinant of AB is equals to determinant of A into determinant of B. Now first of all, find out the product AB. That is a 1, 2, 3, 5, 0, 4, 2, minus 1, and next is 0, 4, 4 minus 2, 0 plus 10, 12, minus 5. This is the normal terms are there. Now perform the BA. First row, first column, first row, second column, second row, first column, and second row, second column. See this here, multiplication if you want to see correctly. This is number 2 and number 1. Therefore, from 1 and 2, their values are not equal. It means that the matrix multiplication is not commutative. That is, AB is not equals to BA. Now we will find out the determinant. AB is equals to, that is a 4, 2, 10, 7. Now find out its a determinant. It's very easy one. That is 4, 2, 10, 7. That is a 28 minus 20, that is equals to 8. And find out the determinant of the individual, that is a and B. Determinant of A is equal, AB is equals to 8. Now determinant of A, that is a 1, 2, 3, 5. That is 5 minus 6 minus 1. Determinant of A is minus 1. And determinant of B is 0, 4, 2, minus 1. That is equals to minus 8. And their product, minus 1 into minus 8, that is a plus 8. Therefore, determinant of AB is equals to determinant of A into determinant of B. And in this way, that is, we have completed up to the question number 25. Now we'll see in the next video. Till then, goodbye. In this way, we have completed the exercise 4.6. I hope that you have understood all the problems, whatever that I had explained. Now we'll see in the next video. Till then, goodbye. Now we'll see in the next video. Till then, goodbye.